Okay, here we go. I don't know about OBS so much, so I have weird audio stuff. So now you can see the web page or our website. And for everything we want to do, it's about AI-AD methodology. The problem in enterprise today is that we have to integrate AI to maximize the productivity of developers, but often we don't know how to do it. So the concept of AI-AD is that you stay in control. And you should amplify the engineering intelligence, not replace it. With this tool, you can analyze your legacy system, for example. You can reconstruct your entire enterprise knowledge, and you can synchronize everything in between. You can very often the knowledge in the enterprise are totally scattered and not up to date. Then you can enterprise rewriting, modernization, refactoring, improving your existing software. You can remove all software as well. Okay, so the idea is that we have many steps to control what you do with AI. So the idea is not to let the AI do whatever she wants anywhere and losing the control. So it's going to be a little bit more work and a bit slower, but on the long term, it's going to be very efficient. Especially because we have a knowledge base. So knowledge base is knowledge of your company. And especially the business specification can be Word documents, it's going to be PDFs or markdown files, text files. Anything the AI can read can be put in this section because it's legacy, but it's very, very important. Then you can define your architecture specification, either something existing, you can explain something existing, or something new. You can specify the coding norms. If you don't have any, you can extract them from the existing code, for example. Integration test definition is all the rules you want to put in place for the integration test. But we'll come back to this in our example. Then with prompts, you will start defining new features. Or something you want to call a feature could be to fix a bug, for example. Or any task you want to do. Then this from a prompt and cloud skills, we will generate a markdown file, which will be f something, f001, f002, and so on, for a specific feature. And with this associated integration test. That all markdown file, we didn't generate any code yet. That's very important because anytime you want to improve something, you want to enhance something or add a new feature, you have to confront on what it's already done. And the example I'll show you later will be very interesting on that aspect. Then from that we will have another skill that from those things to generate both the artifact and the integration test, and we indicate that the LLM must use the coding norms in the integration test definition to generate those two artifacts. At this point, you must be able to run something and to check if it's correct or not. But more than that, more than the execution itself, it's a feedback you will input in this code, because you have to make sure you understand the code. Human in a loop everywhere. And then you will generate a report and proof execution. We'll talk about that later. So the clear idea is to keep in mind that AI accelerates your development, but you have to control it. And you can accelerate as much as you want, as long as you control it. So the architecture stays human control. I mean, if the AI doesn't follow your architecture, you have to fix it. You have to constrain it. You don't have to let it go. It's very important to keep everything in control. If one day, for example, you cannot pay anymore the AI, or the AI becomes so expensive, or the AI is not something, no longer what you want to do, or it collapsed, for example, or whatever, you have to be able to ask a human to do the job. So in your legacy system or in your old documentation, you have a lot of interesting information. So this part must be also accessible from your LLM. And this legacy system, like coding base, for example, but your enterprise knowledge, like all documentation and everything, must be also put in a loop and maybe refreshed or just classified. You can do anything you want. You can just generate new versions of it. You can, but the important is it's here, it's readable. So as we said, the key idea is to keep human in a loop at every step. So you constrain to generate the spec and what you want to do, you constrain it, you verify it, you don't let it go at every step, you just have a look on what's generated, you fix it. Same for architecture, where you have to keep everything in control. Feature descriptions, what we said, we have to generate specific feature for new development, for example, or fixing bugs. Same thing. You ask AI to generate that, but we keep an eye on it. Code and test, always the same. We keep an eye on it, we generate stuff with the AI, but we don't let it go, we just control it. Report and proofs, that's something more interesting and more advanced that you will see later. The goal is to use logs, or specific logs, as a proof of execution, and in case of, let's say, regression, something we cannot easily fix, we can feed the AI with a proof of execution that was right at the time, and to let it know how it was supposed to work at the time. Reinjection.valid knowledge, it's, for example, when you have a new feature and you want to make sure that it doesn't conflict with old feature. So in the end, you won't replace developer. You will amplify experience in engineering teams and you will make your developer more productive. So this is what we do, and that's an example that we just modify that live, but to start something more interesting, I have already generated some files, and I'll explain how I did that.